Okay, so what we're going to do is solve. That's all our directions are going to tell us to do is to solve. And when we solve this system, we're going to look for an ordered pair at the very end. So, if our equations are not written in standard form, that's our first job. If they are, then we start searching for best case, second best case, or worst case scenario. So looking here, we're looking for one variable with the same exact coefficient, but with opposite signs. Do we have that situation, Nick?
Yes.
What we got? Which one?
Positive y, negative y.
Yes, so our best case scenario occurred, yes. Our y's have the same coefficient, 1, but opposite signs. One is positive, one is negative. So what we do is we just go ahead and add our equations together. So 2x plus 2x is 4x. Y plus negative y eliminates, they cancel out, and 7 plus 13 is 20. We divide both sides by 4, and we get x equals 5. So that's half of our answer. Now what we're going to do is we're going to take that solution and we're going to plug it back into either original equation. Now I like to choose the variable I'm solving for. If he's positive, that's the one I tend to choose. So this one, we're going to take the 5 and replace it when we see x. So it's 2 times 5 plus y equals 7. So we get 10 plus y equals 7, subtract 10 from both sides, and we get y equals a negative 3. So right now, I suspect my answer alphabetically is 5, negative 3. Now I want to perform a check to make sure that that's correct, so I'm going to test out 5 and negative 3 in each of the equations. So 2 times 5 plus negative 3, the question is, does that equal 7? So 10 take away 3 is 7, and 7 equals 7. So yes, it works for the top equation. Bottom equation, 2 times 5, take away negative 3. Question is, does that equal 13? 10, and then double negatives make a positive, plus 3, and I get 13 equals 13. So since it satisfied both equations, then I know my answer is 5, negative 3. Okay? All right, let's try another one. This one, we have 2a minus 3c equals 20. And a minus 3c equals 13. So do we have a best case, second best case, or worst case scenario on this one?
Second best.
Second best. And what makes it, Michael, second best?
Because you have 2 negatives.
Yeah, if you look at the 3c, both of them are negative 3c. So what is our solution to get them to be opposites? Rachel,
You multiply one equation by negative 1.
So what we're going to do is alter one of the equations. And I'm going to alter, and it doesn't really matter which one, I'm going to alter the top equation. And to do that, I'm just going to multiply each term by negative 1. So that creates this new equation. Actually, let's make him pink. So we're going to get negative 2a plus 3c equals negative 20. Now that I've created the best case scenario, I can go ahead and add the black equation, the a minus 3c equals 13, and the pink equation, the negative 2a plus 3c equals negative 20. So when I add, let's see, I get a minus 2a is a negative a, the negative 3c and positive 3c eliminate, and 13 take away 20 is a negative 7, and then I just divide both sides by negative 1, and I get a equals 7. Okay? Now I'm going to take that answer, and I'm going to substitute it back into either original equation. I'm going to plug it back into this guy, because it's going to require less work, because there's no coefficient in front of the a. And I replace 7, I substitute in 7 for a, minus 3c equals 13. And then I just solve it. So I subtract 7 from both sides. I get negative 3c equals 6. Divide both sides by negative 3. Signs are different. I get a negative, and 6 divided by 3 is 2. So I take those two answers, and I'm going to write them alphabetically, A, C. And then I'm going to go ahead and check my work and see if 2 times 7, the A value, minus 3 times negative 2, the C value, does that actually equal 20? So I get 14 plus 6, double negative makes a positive, and I get 20 equals 20. So it satisfied the top equation. Let's try the bottom one. 7 minus 3 times negative 2, does that actually equal 13? So double negative makes a positive 6, and I get 13 equals 13. So it satisfied both equations, which means 7, negative 2 is a solution to this particular system. Okay. All right, let's try another one. Now we're going to get into not so pretty ones. So we have 2x plus 3y equals 12. And we have x minus 4y equals negative 5. Best case, second best case, worst case. Oh, it is the worst case because we don't have a match. So here's what I do. What I'm looking for is one of two things. Because there's variations of worst case. There's okay worst case, and there's like totally worst case. This is actually an okay worst case. You look at one variable and you ask yourself, are those coefficients multiples of each other? In other words, if I multiply one coefficient by something, do I get the other coefficient? That's the okay worst case scenario. Okay, so do you guys see a variable that would fit that condition? That if I multiply one by a value, it will match the other. Okay, and Ryan, what do you see?
I see the second x, if you multiply it by 2, you can get the top one.
Okay, great. So if coefficients of 1 are awesome, because I can deal with that really easily. But I'm going to make a slight correction. Ryan said to multiply the second equation by 2 to get the match. Does that make it the best case scenario or the second best? Second best. To make it best, Ryan, let's multiply by that negative 2. Good. So let's go ahead and we're going to multiply that entire equation by negative 2. Everything. Oop. Okay. So that equation now becomes negative 2x. And then we have a negative 4 times a negative 2 is a positive 8y equals a negative 5 times a negative 2 is a positive 10. Now I'm going to bring down the top equation. And what I've just done is I've just created the best case scenario. So now I'm ready to add and eliminate. So when I add negative 2x and positive 2x, they are opposites and they eliminate. That leaves me with 8y plus 3y, which is 11y, equals 10 plus 12, which is 22. Divide both sides by 11, and I get y equals 2. Oops, that's a lousy looking y. So now what I'm going to do is take that y equals 2, and I'm going to substitute it into either original equation to solve for x. Now I'm picking the second one because the x doesn't have a coefficient, so it's going to actually require less amount of work for me. So I have x minus 4 times the y value 2 equals negative 5. So I have x minus 8 equals negative 5, and I add 8 to both sides. And I get x equals 3. So I'm going to take those two coefficients, or two answers, put them together as an ordered pair alphabetically, 3, 2. And then I'm going to make sure that I check my work. So 2 times 3 plus 3 times 2. The question is, does that actually equal 12? Well, 6 plus 6 is 12, and 12 definitely equals 12. So it worked for the top equation. Second equation. And notice that I'm going back to the original equations. 3, oops, sorry, that should be a minus. 3 minus 4 times 2, does that actually equal negative 5? So 3 take away 8 is negative 5, oops, negative 5, and negative 5 equals negative 5. So that makes me feel confident in my answers 3, 2. Okay? All right, you guys ready for the worst case, worst case? No. You know? Okay, well, ready or not, here it comes. So the worst case, 5x minus 2y equals negative 5. 3x minus 7y equals negative 32. Worst case, worst case. Why do I say that? Logan, why do you think I'd say worst case, worst case?
Because you can't multiply just one to make the other. You have to multiply both.
Yeah, I can't multiply just one equation by a number to get a match. It's impossible. What else would make it worst case? Is there anything going in our favor here? James?
No signs.
Yeah, both x and y's have same signs. So I don't even have one that already has opposite signs. So not only do I have to multiply both equations by something, I also have to multiply by a negative to get my signs to be opposite. So then it comes down to, well, what do I multiply by? How do I make that decision? Andy, what do you think?
On the bottom one, you can multiply by -2, and then the top by 7.
Okay, so what is it that you're trying to eliminate?
The y's.
Okay, so here's what Andy's saying. Let's focus here on the y's. And he says, if I want to get rid of the y's, why don't I just take the coefficients that are there and multiply the top equation by the coefficient of y from the bottom, and multiply the bottom equation by the coefficient of y from the top. So let's try that. Let's multiply the top equation by 7, because that's the coefficient on the bottom. Now we are going to have to multiply by a sign, and so I tend to multiply by the negative on the bottom. I don't know why, that's just me. And then I'd multiply the bottom by the coefficient of y on the top, which is 2, but I'm going to also add a negative, because I do need the signs, bless you, to be opposites. So the top equation, and this is why the worst case scenario is the worst case scenario, because you get bigger numbers to deal with often. We get 35x, minus 14y equals negative 35. For the second equation, we get negative 6x plus 14y equals positive 64. Now what I've just done is artificially created the best case scenario. So if I add my equations together, my y's are going to eliminate. Now, let's see, 35 take away 6 is going to give me 29x. And over here, if I rearrange this, I'm going to get positive 29 over here. So, wow, even though those numbers seem to look ugly, look at how beautiful it turned out. So I get x equals 1. So I'm going to take that value, and I'm going to plug it back into either original equation to get the y. And again, I tend to choose, if I can, coefficients that are smaller. I can't avoid negatives, so I'm just going to have to deal with it. So 5 times its value of 1 minus 2y equals negative 5. So 5 minus 2y equals negative 5. I'm going to subtract 5 from both sides. I get negative 2y equals negative 10, and then I divide both sides by negative 2. And I get y equals 5. So it appears my answer is going to be 1, 5. So appearance is not good enough, we're going to check. So 5 times 1 minus 2 times 5, does that actually equal negative 5? So I have 5 minus 10 is negative 5. So it satisfies the top equation. Second equation, 3 times 1 minus 7 times 5 does that actually equal negative 32? So 3 minus 35 gives me negative 32 equals negative 32. So what that says is, yep, that's a good answer. All right, good job.